The community of Alpine has a long history of being a rural area. In the 1920s, Alpine Boulevard was built as the new Highway 80. Then, in 1969, Interstate 8 was constructed and it connected Alpine to the city of San Diego, which eventually helped Alpine's population grow. Even through these advancements, the surrounding areas of Alpine Boulevard remain a rural area. Recently, there has been an increase of traffic safety issues and flooding due to the population growth of the surrounding areas. For this project, A.V.A.C.D.O was tasked to redesign and to renovate the current conditions of Alpine Boulevard between Tavern Road and East Victoria Drive.
The hydrology study was done to identify current problematic areas due to excess runoff surrounding the 2-mile stretch of Alpine Boulevard. The hydrology study was done using hydrology requirements given by the County of San Diego Department of Public Works Flood Control District. The methodology used to conduct the hydrology analysis was calculated by the rational method to compute stormwater runoff rates and volumes of the project site. Before conducting the rational method, the amount of water basins had to be identified along Alpine Boulevard. First, a topo of Alpine Boulevard was used to identify the location and was placed on top of an AutoCAD drawing of Alpine Boulevard. By doing this, the elevation lines given from AutoCAD made it easier to identify the placements of the water basins. By using these contour lines, 6 watersheds were identified along Alpine Boulevard. The 2 largest watersheds were identified north of Alpine Boulevard. They were described as System 1 and System 2. Heading south of Alpine Boulevard, 4 other systems were described: System 3, 4, 5, and 6. Once the watersheds were identified by separate systems, the area was calculated for each, and then the rational method was used to calculate for the flow. The next step after calculating the flow was to begin designing for the culverts.
The largest watershed is located northeast of Alpine Boulevard, and the endpoint was at the intersection of Alpine Boulevard and Vista Alpine Road. To alleviate the flooding issues, A.V.A.C.D.O redesigned a culvert for a 50-year flood. Nomographs were used to determine and calculate the proper size and entrance shape of the culvert. The structural analysis of the culvert included the analysis of dead loads of the soil and the live loads of the traffic.
The site has a continuous elevation not more than 4.5%, with elevations ranging from 1,700 feet to 2,032 feet above mean sea level. The boulevard contains existing asphalt pavement, concrete walkways, landscape areas, and grassy areas with large trees. The potential for a major erosion in the area in the short run is minimal. However, there will be check dams strategically positioned away from downstream with rock slope protection. This should be enough to mitigate any erosion problems along the boulevard. The only potential area that could be affected by scour is the proposed culvert area. However, concrete rock lining is going to be placed in the channel bed underneath the culvert wash, 3 feet with the top of the rock lining to match ground elevation. The field investigation consisted of a visual reconnaissance of the site and the drilling of 3 borings. The borings will drill to depths up to about 10 to 15 feet below system grade. Penetration test samples and bulk samples were collected from the boring for laboratory testing. Our laboratory testing included dry density and moisture content, percent of sample passing the number 200 sieve, R value, assumed based on how we designed manual, maximum density, and optimal moisture. These are our recommendations based on the lab data. Retaining wall. Wall should contain an adequate sub-drain to minimize hydrostatic forces. Therefore, backfill should be compacted to 95% optimal. Maximum dry unit weight to minimize settlement on the backfill. Drain pipes. For the truss blocks, should have an allowable bearing of 2,000 pounds per square feet, a passive pressure of 350 pounds per square feet of embedment, a coefficient of friction of 0.35. Pipe bedding. As a minimum, the pipe should support it on at least 4 inches of granule soil bedding material, such as 3/4 inch crushed rock. Pavements should be designed with a traffic index of 7. The asphalt section should consist of rubberized asphalt over 2 inches aggregate base over properly prepared subgrade. The subgrade soil should be proof rolled prior to placing the asphalt section and compacted to a 95%.
The objective of this project was to increase safety while maintaining the rural atmosphere. Some of the steps that A.V.A.C.D.O took to keep the rural look of the city of Alpine were to keep in mind not to add sidewalks along the whole corridor, to eliminate the traffic lights on the 5-point intersections by replacing it with a roundabout that would only need yield signs to operate. In addition, town hall meetings will be held to get some input from members of the community on what they would like this project to look. The main areas with high safety risks are the parking entry and exit, roadway width, intersection optimization, and cyclist and pedestrian safety. For the bicycle section of the project, the goal is to provide a consistent bike lane path that will flow through the 2-mile span of Alpine Boulevard while providing appropriate space for parked cars and a traffic lane. The byway classification selected for this project is a Class 3 bike route designed through the span of Alpine Boulevard. This type of bikeway provides a consistent design for shared use with pedestrian or motor vehicle traffic, which in turn requires the least space. For pedestrian crossways, currently on Alpine Boulevard, the only safe places to cross are on the intersections on Tavern Road, Victoria Drive, and East Victoria Drive, which are approximately 1 mile apart. These are safe pedestrian crossings because there are traffic signals that force automobile traffic to stop in order to yield the way to pedestrians. In between the streets of Tavern Road, Victoria Drive, and East Victoria Drive, there are no designated pedestrian crossings. Due to this, we decided to add 2 more crossways. The objective of implementing 2 pedestrian crossways is to create an environment where pedestrians will be able to cross Alpine Boulevard safely from one end to the other in various locations. In addition, the crossways will be raised in order to increase safety that will force vehicle speeds to drop in these certain areas. The purpose of the parking study is to improve the safety of the egress on the parking lots located directly adjacent to Alpine Boulevard, while trying to maintain the same number of parking spots. This study involved both research and survey components, including literature, research, data analysis, research of parking requirements, and survey parking demand for the area surrounding the 2-mile stretch of Alpine Boulevard. The main outcome is to provide the safest design options for drivers and pedestrians. During the redesign phase, we took a new approach to achieve a solution that will benefit the community. The first step was to redesign the parking lots in such a way that each slot will get re-angled at 30 or 45 degrees. By re-angling these slots, we were able to give drivers a better line of sight.
By using a roundabout, the safety of the intersection is improved while making the flow of traffic more constant, since they don't have to wait for the traffic light to turn green. A roundabout is safer since vehicles have to go around the circle at lower speeds. Also, the decision making is simplified since it is a yield upon entry. Due to this, on the 5-point intersection of Alpine Boulevard, we decided to implement a 115 diameter roundabout where cars can travel at 14 miles per hour. With the roundabout in place, we were able to eliminate car accidents. In addition, on the pedestrian crossings, we recommended that timed crossing lights be installed to improve the safety of pedestrians. The purpose of this road design study is to improve the 2-mile stretch of Alpine Boulevard from Tavern Road to East Victoria Drive, such that it meets current standards while maintaining the current natural setting. Since one of the criteria was to keep the rural setting, the current number of lanes had to be maintained. The road classification chosen is a light collector with race medium 2.2A to abide by the lane criteria and the County of San Diego public road standards. This classification is a series of dimensions and specifications that are outlined on the County of San Diego Public Road Standards Manual. Based on them, the roadway had to be 12 feet wide with a shoulder of 11 feet with a race medium of 14 feet wide with a proposed speed of 40 miles per hour. In order to provide enough space for public transportation buses, the locations where bus stops are present will be modified. Instead of the normal 11 feet shoulder that is throughout the boulevard, at these locations a 14 feet shoulder will be used. Typically, the majority of boulevards carry heavy traffic, such as buses and trucks, and this is not the case for this particular project. since the traffic on Alpine Boulevard is formed mostly by residents and neighbors. The engineers in charge decided to use specialized material which would extend pavement design life, rubberized asphalt concrete, because of the resistance to cracking and aging exhibited by rubberized asphalt roads paved with this material generally experience longer service lives before maintenance is required. Rubberized asphalt generally resists the formation of cracks better than conventional asphalt. It exhibits more elasticity than unmodified asphalt, but it also shows a greater resistance to aging. Throughout the span of Alpine Boulevard, signage will replace the old, outdated signs. Throughout the different construction phases, new signage will be posted to complement the new construction. The new signs that will be posted pertain to the roundabout, bicycle route, and handicap parking spaces.
The most important element while designing the construction phases was pedestrian and vehicular access to the Alpine Boulevard. The entire project was divided into 3 phases with the only purpose of having the most part of the boulevard with regular activity. For the construction phases, pedestrian and vehicular access will not be restricted. Alpine Boulevard, it is a community of houses and small businesses which will suffer economic impacts if the street were temporarily closed. Also, another area of reconsideration was the elementary school. During school hours, the construction crew will monitor pedestrian crossings for students and school staff all the time. Similarly, the construction group will provide pedestrian and traffic monitoring during the use of operation of any type of equipment, either light or heavy. For the construction of Phase 1, it's going to require 28 of work days. Construction 1 goes all the way from East Victoria to West Victoria. For construction of Phase 2, it will take 66 work days. Phase 2 goes all the way from Tavern Road to West Victoria Drive. Phase 3 will consist in the construction of the roundabout intersection. This will consist of 16 workdays.
For the cost estimate, the County of San Diego Department of Public Works Land Development Division unit price list was taken into account as the only cost estimate guideline. The cost estimate was divided into 6 different sections: surface improvements, traffic, storm drain systems, earthwork, landscaping, and miscellaneous. However, the most expensive section was miscellaneous. The 1,300 feet long cast-in-place concrete retaining wall was 90% of the cost estimate calculated for this section. The second most expensive section was surface improvements, due to removal of the existing asphalt and the use of rubberized asphalt for the repavement. After analyzing all the elements needed for this project, the total cost estimate was $11 million.